All right, here we go. Third and final video of the day here. A lot of videos today. It's just too hard to teach all this at once in one video. I talked about boiling point, vapor pressure, and freezing point, melting point, same thing, are also colligative properties. So I'm just going to tell you what happens and then give you some examples and then show you the worksheet. Keep this less than 10 minutes. Both melting point / freezing point and vapor pressure decrease in a solution. So what that means is if you have a pure solvent, so if you have, let's say, H2O, pure water, and then you have salt water, NaClAq, so that example I just used in the last video with 0.1 molar and 1 molar, the boiling point goes up. Add a solute, boiling point goes up. Add a solute, boiling point goes up. I'm going to put the video in the classroom, and if you watch it, you watch it. If not, then obviously you won't. But it's a song, and it's catchy. Add a solute, boiling point goes up. Add a solute, freezing point goes down. Add a solute, freezing point goes down. So actually, I'll write that. Add a solute, freezing point goes down. Sorry, I'm running out of room. All right, so here's what that means. Water freezes. Whoops. Water freezes at 0 degrees. Salt water freezes at, let's say, -5 degrees Celsius. That's it. There's not much else I can show you as far as numbers. I'll draw pictures, show you the homework worksheet that you're gonna do. But if you add particles to water, add a solute, it disrupts the forces of attraction. There's more forces, so it has to be even colder for that freezing point. Sorry, freezing point. Right, freezing point of these would be -5. Right, so that's okay. Here we go. Right, that's like, let's say, 0.1 molar. So you add 0.1 moles of salt. If you have 1 molar NaClAq, and these words 1 molar, and I know that's confusing. We're going to learn that next. That's more salt. 1 is bigger than 0.1. So let's say that's -10, right? So the more solute, the more forces, the lower, add a solute, freezing point goes down, the lower the freezing point is. Vapor pressure is the exact same. And before I talk about vapor pressure, basically what I need you to understand is if you have a pure solvent like water, it freezes at 0, boils at 100. But if you have something like salt water, it freezes at, let's say, -5, and it boils at 105, right? So we're freezing down here, boiling up here. It stretches that scale. That's what it does, right? Because there's more forces, so it needs more energy to boil to break those forces, and it has to lose more energy to freeze and form crystals and form solid. Okay, I know this is hard remotely here online, and there's stuff I can show you in class, but it is what it is. All right, so vapor pressure also decreases. What does that mean? All right, well, if you have a beaker of water and a beaker of salt water, right? So you have particles in here. All right. Actually, here, let's do this. All right. So let's say the water particles are blue. Okay, so stay with me here. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, now assume these beakers are identical. All right, now I'm going to use red for salt. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's say I add 10 salt. So over here we have pure water. So this is just water. This is salt water. Okay. These water particles will evaporate, and these water particles will evaporate. If I have salt water sitting on the table and I have pure water sitting on the table, both of them, the level will slowly decrease because water will evaporate. However, what happens is this will evaporate faster, the water will evaporate faster than salt water. So what that means, and I can't really show this animation very well here, but they're both going to produce water vapor particles, right? I know they're not very spread out, but we have vapor up here. All right, so here's my vapor. Here's my liquid. This is going to produce less. Okay, actually, it would be significant. So here's my vapor. And the reason for that is the forces of attraction holding the water down. I think of the salt, Na plus, CO minus, are like anchors, right? So let me use a different color. This is gold, brown, whatever. So these particles are attracted to each other. These particles are attracted to each other. These particles are attracted. These particles, So salt and water are attracted. Therefore, the water can't get out. So it's like little anchors keeping the water down. So if we're going to measure the pressure up here and the pressure up here, which is vapor particles bouncing around and colliding, that creates vapor pressure. There's going to be way more vapor pressure. So higher vapor pressure here and lower vapor pressure here. So at a solute, vapor pressure goes down. There's less vapor because there's forces keeping it down. Why would the water want to evaporate? It would rather be attracted to salt. That's the whole point. That's why it forms a solution. It's attracted to each other. They are attracted.